Alright, so this chapter is entitled Organic Molecules of Life. So we're going to talk about organic versus inorganic, carbon molecules, and the synthesis and breakdown of molecules. Okay. So what is an organic molecule? Okay. And I think that when you first think about this term, you're probably immediately going to organic produce, but it's not the same. So in order for a molecule to be considered organic, it has to contain carbon and hydrogen in the same molecule, okay? So carbon plus hydrogen equals organic. And this is what is largely makes up our cells, tissues, and organs. Then the next question I would say, well, can you name some organic molecules? What are some molecules that you know that have both carbon and hydrogen in them? If you are familiar with chemistry, you might go to the gases, methane, ethane, propane, butane. So if you'll see here, you see carbon and hydrogens, okay? Carbon, hydrogens, that's all they contain. Now, in order to be organic, it doesn't have to only be carbon and hydrogen, but it has to be carbon, hydrogen, plus some other things. Can you think of anything else that are organic molecules, okay? So you should think of sugar. C6H12O6, okay? So carbon and hydrogen, and it has oxygen, but it has carbon and hydrogen, so it is organic. Then what is an inorganic molecule? So now an inorganic molecule is going to be a molecule that doesn't have both at the same time. So it can be a molecule that has carbon, it can be a molecule that has hydrogen, but it is not a molecule that has hydrogen and carbon, okay? Water, H2O. Water does not have carbon and hydrogen in it at the same time, so it is not an organic molecule. Now, you should remember this. What four molecules make up 95% of all living things? This will be your carbon, hydrogen, oxygen, and nitrogen. And then the other ones will be phosphorus and sulfur. And together, those four make up the majority, and then those other two are also, you'll find in all living organisms. Okay? So let's talk about carbon. What makes carbon so special? So remember, carbon is necessary with hydrogen to be organic, and we are largely carbon-based organisms, right? Why carbon? Why not oxygen? Why not hydrogen or something? Okay? One of the reasons is, well, let me back up. I'm jumping the gun. So first, I'll start by telling you that, all right, so carbon has an atomic number of 6. The letter is a C and an atomic weight of 12. And you should remember that the 6 represents the number of protons, which equals the number of electrons in an electrically neutral atom. And then this 12 is the atomic weight, and you can use that minus the protons to give you the neutrons, okay? And so, because carbon has 6, then we know that, because carbon has 6, then we know if this is the N, and then our shells, right? And we know in that first shell we have 2. So that leaves 4 in its valence or outer shell, right? And then that means how many does it need to be full? It needs 4, right? So carbon can essentially form 4 bonds. And we've seen that when we looked at butane, was it? CH4? And you can see, make sure I'm telling you the correct thing. Methane, sorry. So here's its carbon, and it's forming these 4 bonds, right? And that makes it full. So our carbon can form 4 different bonds. So because of this, carbon is what we made of, because you can have this one carbon molecule and you can essentially attach 4 different molecules to it. Okay, so this is it in what I just drew. So you have your 6 neutrons and protons, 6 electrons. You have the ability to form 4 bonds. So carbon is good at forming bonds. It can form a single bond. It can form a double bond, where it's sharing 2 electrons with the same molecule, or even 3 and forming a triple bond. It can form bonds with itself. It can form bonds with other atoms like hydrogen, nitrogen, oxygen. And you'll notice these are all what's making up the majority of living things. So far, so good on organic, inorganic, and carbon. The last thing we're going to talk about in this video is synthesis and breakdown. So build them up and take them apart. And this is important with our macromolecules because essentially a macromolecule is a large molecule made up of several different subunits. So those little subunits are called monomers. Okay, so those little small pieces are monomers. And so when I ask you, hey, what's the monomer of this macromolecule, right? You'll know that the monomer are those building blocks that we put together to make that macromolecule. And that macromolecule can also be called a polymer or many monomers joined together. So how do we join these monomers together? So this is our dehydration synthesis. And when you think of dehydration, you think of a lack of water, right? So it's called dehydration because we are removing a water in order to join them together. So we have our two monomers here, and they all have these hydroxyl or OH groups. When you put them together, water is coming out. So we take that water out and then join that oxygen, okay, or join these two molecules by that oxygen. So this loss of H2O makes this a dehydration synthesis. We're losing water, okay? And so here we are looking at monomers, taking water out and just adding them until we have a larger molecule. So 1 plus 1 gave us 2, plus another one 3, plus another one 4, okay? But every time you put a monomer together, you're losing a molecule of water. Then, how do you break it apart? You do the opposite. So hydrolysis, so we're going to lyse a molecule of water in order to break apart these molecules. Okay, so we have that O from the beginning. Remember, we join these together by oxygen. Now, a water comes along and says, I want to join you, so we're going to break apart that O and add that other O back. Okay, and in order to fill them, we have those hydrogens. So hydrolysis is the addition of water to break apart our monomers. Or we're going from a polymer back to its monomer, or a larger thing back to the smaller subunits. And this is hydrolysis. And this is the similar thing. We have 4. Add water, remove 1. Add water, remove 1. Add water, remove 1. Until we're down to single subunits. Okay? So with a dehydration, you're taking water out to join smaller subunits together. With hydrolysis, you're adding water back in to break apart the large into the small.